Introduction and purpose. This lab is intended to 1. Calculate the mass of a black hole given the orbit and forces by a star orbiting it. 2. It is used to project the path of the ship as it is affected by both the moon and planet's gravitational forces given a starting velocity. Fnet is defined as the sum of all forces, and for this case is the sum of all gravitational forces by the respective surroundings. The physics principles used in this lab are Newton's second law and universal gravitational forces. The system for the first part is the star, and for the second part is the ship. The surroundings for the first part is the black hole, and for the second part is the planet and the moon. This experiment was entirely code-based, so GlowScript was exclusively used as far as software. GlowScript in this case was used to calculate the mass of the black hole and project a path of the ship given the starting velocity and gravitational forces of the planet and the moon. In this experiment, I found difficulty establishing a figure-8 orbit around the planet and the moon, but I was able to establish a path that was affected by both gravitational forces. For our physics equations, we used both the position and velocity update formulas and the universal gravitational formula. For the position and velocity update formulas, it was just so we could use those to track the orbits of both the moon and the spaceship and of the star, as the net force could have changed, and for the ship it did. For the universal gravitational formula, we use that to 1. Find the mass of our black hole, and 2. To establish the forces and eventually the net force affected on our spaceship and the moon. These are our results. The top shows the orbit of the star around the black hole and the fact that we found the mass of the black hole to be 1.4 times 10 to the 34th power kilograms. And the bottom image shows the path of the ship in purple and the orbit of the moon in cyan around the dark blue planet. I was unable to get the figure 8 as I mentioned before, but the path is being affected by the gravitation of both the moon and the planet, noted by its drifting pattern. This first piece of code gives us velocity, and we're using that to find the change in velocity, momentum, and our Fnet. We then break down Fnet into its components, Fnet parallel and Fnet perpendicular, and we use those to show the breakdown of forces on the star in our picture. We also used the universal gravitation formula rewritten to solve for m to find the mass of our black hole. In the second part, we used the top code to initialize some of our constants, and we set our initial velocity for our ship. The bottom code initializes the position and forces on the moon and ship and uses the position and velocity update formulas to track the position of both the moon and the ship. The forces are calculated using the universal gravitation formula. Possible errors and what ifs. We possibly could have chosen a better starting velocity for part 2 to get a stable orbit. We possibly could have erred in choosing the mass of the black hole because I took the final mass out of the data instead of averaging it all. What does it mean? The rate of change of momentum could be negative, but our net force could be positive. Change in momentum just kind of is where the object is going, whereas the net force could be pointing somewhere completely different, just slowing it down. What if? If these two models were combined, each smaller mass would feel the gravitational forces of all the larger masses, and thus the black hole would have the dominant effect over the experiment.